All right, so let's now go over the three kinds of methods one by one. Let's start with the constructor. And of course, it is for you to create instances of a class. And then a constructor may declare input parameters, or maybe simply just empty, for example, default constructor. And also, you may use to initialize some or all of the attributes. We'll see some example of that later. But just the bottom line is you don't really have to initialize all the attributes in a constructor. That's why you may have multiple versions of constructor. Okay, you can define one or more constructors. And remember, in the tutorial video, we show you if you simply do not declare explicitly any constructor, the default one will actually be available to you, right? Just remember that. And the name must be matching the class name. And also, there'll be no return type. And also, they must have distinct lists of parameter types. So let me explain to you a little bit further by giving some example. Let's say, for example, in your person class, if you have the list of two constructors over here, let's say you got string name and also string name and also age. You got version 1 and version 2. Would this be allowed? The answer is yes, because it's easy in this case because you simply got two lists over here. And list number 1 has size 1, and list number 2 has size 2. So that would definitely be considered as distinct for sure. If you got simply different sizes of parameter lists, that would just be fine. So this will be okay. Okay. What about second one? Let's say you got two constructor over here. So in the first case, you got a list of size 2. And for the second version, you also got a list of size 2. Would this be okay? The answer is, for this example, yes, because you can see the order of the parameter types actually matters. So you can see the first one, string followed by integer, and the second one, integer followed by string. So it will be considered also as distinct lists over here. So that'll be okay. And notice that I didn't really emphasize too much about the name of the parameter. So as far as the Java compiler is concerned, they only worry about, number one, the size of the parameter lists, and also number 2, the types that are contained in the list. So in the names of the parameters are simply not relevant. Let's see another example. Let's see over here. So we also got two versions over here. You can see again, they got two lists over here of size 2. So now we have to make sure the types can really distinguish between the two constructors. But now, so for the first one, we got first name. And seems to be different because for the second one, we got last name. And also for the second one, we got age and also ID. So would this be okay? It turns out this is not okay. You can try that to define these two constructors in the Java compiler. In the Eclipse, the compiler will complain. Because as far as the compiler is concerned, you got one list which start with string followed by integer. You got another one also followed by start with string followed by integer. So now let's say this. If you say person Jim 23, in that case, are you really saying the Jim? Would that be qualified as first name? Would that be qualified as last name? And also for 23, would that be qualified as age? Or would that be qualified as ID? So we got ambiguity over here, right? So that's that's really what I meant by distinct lists over here. All right. Okay, and then each parameter is supposed to initialize an attributes, right? You can use the parameter for that purpose over there, and it must have a matching type. We got some example later. And then the body of the constructor should really specify how some or all attributes may be initialized, right? And let's consider some example here. Let's say for the point class, let's say we got two versions of constructors. Version number 1, we're going to initialize both the x and y using the two parameters. And for now, I simply choose the names of the parameters that do not clash with the x and y. So that means in the body of the constructor here, I do not need to use the this keyword, right? That's something we also explain in detail in the tutorial videos. And version number 2, let's say we may want to specify whether we want to put a point either in the x along the x-axis, in which case the y value will always be 0. Or if we want to put the points along the y-axis, in which case the x value will always be 0, right? So that means in the body of the constructor, I'll let you study that. So you can see we either try to assign to x or we try to initialize y, but we don't really initialize both. It's conditional. So that means we only initialize some, but not all of the attributes. So that's one example. And then in the case of else, you may just set some attribute value to say the status will just be invalid because you cannot really handle anything other than x and y for the parameter over here, right? So that's just an example. And then you can also go through the example for constructor for person, pretty much like how we did it for member in the tutorial video. All right, I'll let you study that. And also notice that I actually chose the names over here, not clashing with the attribute values. That's why we don't have to use the keyword this. We'll get to the this keyword in just a moment. All right, and let's talk about visualizing object at the runtime. I will do visualizing and tracing using the point example at the very end once I have gone through the all the methods. But for now, let's just see the diagram. Okay. And it's really for you to beneficial and effective for you to trace the program. Okay, so for example, whenever you want to create an object using constructor, and also you want to use accessor method or you want to use a mutator method. For example, so here you can see the context object gym, and also context object gym, and also the object you're trying to create. You can all visualize them on the paper, so that will be very beneficial for you to trace. Right, to visualize it, what we said is you're going to draw a rectangle box, right? You can go over the definition here. I don't really need to read it off. I already said that in the tutorial video as well. Let's see the example right away. So let's say this, we're calling the constructor for person. So now after that, you'll see Jim stores the address of this particular person objects, right? You can see the title here tells you the type for the objects, and then the left column here tells you a selective list of attributes that'll be the structure, and the right column over here, for example, 50 would be the instance specific value for the attribute, right? Okay, that's good. And notice one thing more, and Jim is storing the address only. Jim does not denote the address directly, only store its address. And then when we want to trace about how to make a method call, for example, get BMI, and in the tutorial video we talk about get BMI report, right? So I'm not going to repeat. Right, so that one there, you can see whenever you want to say gym.get BMI, so gym dot over here is really like a following through the address of gym and goes follow the arrow accordingly, and you will see this particular person objects. So when you say get BMI, you're going to use all the relevant attribute value, for example 80 and 1.8 to really calculate the BMI, right? That's what we spoke about. So drawing the boxes and with the the relevant values will be very beneficial for you to trace. And similarly, if you want to call mutator method over here, let's say gain the weights by 10. Similarly, once you say gym dot, right? That's going to say gym and follow the arrow. That means we want to modify this particular objects, and we're simply going to change the weights from 80 and increase by 10. So that will become 90. So if you call gym.get BMI again, it's going to give you the new BMI, right? That's exactly right. So you can see now you will be using 90 as opposed to 80. So that's also something we trace in the tutorial video. Now this part over here, just to emphasize the point again, how effective it would be if you try to visualize your object creation. I'll let you read the details over here, right? That's something we have gone through already. I'm not skipping any conceptual details. All right, about object creation, so we got, it's really important to emphasize once more. So for example, if I got this single line over here, because I'm using the new keyword, so that means I'm creating a new object. Remember, we split this particular line into three parts. Part number one, we are allocating the memory for this particular new objects, and then we're going to call the constructor initializing x to be 2 and y to be 4. And step number 2, we are declaring this particular object variable or reference variable p1, meaning that p1 is only going to store the address of point objects only. And then the equal sign over here is the assignment, variable assignment, meaning that we're going to assign the address of this new objects and store that into P1, right? These are the three steps, right? Let's see that quickly. Step number 1, the right-hand side over here. This part here, we're simply creating this object over here, right? Just creating this object, and the object definitely got some address. And step number 2, we're declaring this reference variable P1. So that means it's only going to store the address of some point objects. It cannot be any arbitrary kind of object. It has to be point, because that's what we declared the type to be. And then number 3, the assignments, which is this part over here. In that case, we're going to store the address into it, right? And we might copy address around, which will result in aliasing. That's something I will speak about later. Okay, so that's about, you can think about the assignment here. It's really about P1 is now storing the address of this particular object. That's why you got this error over here. And whenever you say P1 dot some method, you're really saying go check it out, the address that's stored in P1 and follow it to the memory. That's why you follow this arrow over here. All right, and then you can do the same reasoning over here for the person object case, right? I'll let you read the slide, right? The same argument here, just another example for you. Okay. All right, object creation. Let's say this. Let's say I create a new point object over here, and then I simply say, you can try this out. There's something I didn't try in the tutorial video, I don't think. I only show it to you on the debugger, but you can try it out. Print to the console P1. What this will do by default is going to print out just the address for the point object, right? So that's, well, that's not really completely useless. At least you know it's a distinct object you have created. And then, however, if you want to print out the contents for the objects, you may just want to print out the relevant attributes. But remember, we declare all the attributes to be private. So you will have to call the relevant accessor methods. For example, you might just say p1.getX and also p1.getY, and then just print out to the console, for example. Or you can use the JUnits to check it, right? So that's what you will get. All right. All right, and then let's speak about just about initializing attributes. You may not have to initialize all of them. Let's see this. So let's see example here. You can see this one, x to be 3, y to be 4. We initialize both of them, and also -3, -2. But this one here, you can see we are going to create a point along the x-axis, which means the y value is always 0. So y value will be the default value. On the other hand, you can see this one, we're going to create the points along the y-axis. So that means the x value will always be 0, the default, right? So now if you see the visualization, let's see this. You can see the first one, it will be 3 and 4, and also 3 and 4, right? It's straightforward. And this one, along the x-axis, which means the y value will just be 0, and the x value will just be 5, right? You can see this is 5.0 correspond to the default, 5.0 here correspond to the input parameter of the argument value, and the 0 over here is simply the default value. Okay, and similar here, you can see here the x value will be the default value because we only assign the value to the y to -7. All right, and then there's another. Okay, let's see this. And yeah, this is just another example here, just for the person class, right? I'll let you read it. Okay, this one here, we also got, for example, you can see this one, we only initialize the age and also nationality. But this one here, we only initializing the weights and also the heights, right? So that means some attributes are not initialized and will be initialized by default automatically. Okay, and if you see that, for example, you can see, let's say for this one here, so we're only initializing the age and also nationality, right? You can see age and nationality. So that means the weights and heights, they are default values. On the other hand, we are only initializing the weights and heights. And you can see the weights and heights over here are initialized accordingly, but the age and nationality will just be left as default value. And notice that for string is a reference type, so that means the default value will just be null. Okay. All right, and then so this slide here just about checking the argument value, and this is something I just spoke about, how you can check the validity of method call. So the example here should be quite straightforward. I'll let you read it. Okay, and let me talk about the second point. So when you're creating any object instance, initialize attribute implicitly get assigned by the default value, right? So that means you really want to make sure you initialize them maybe later properly using Mutator methods. So here you can see here, after creating the person object using this version of the constructor, where we already initialized the age and also the nationality over here. So that means the weight and heights are uninitialized, just 0.0 default value. That's why we are using these two Mutator method to set them up later, right? You want to make sure you do that. All right, and then let's now talk about the dot notation. And for this week, I will only talk about the simple usage for the dot notation. You can use dot notation for different purposes. Number one is a binary operator. So left hand side is going to be some object expression, and the right hand side is going to be some attributes or a method. So this will be the simple usage we're going to focus on today for this week. And let's see this. And it's really important to say the left-hand side, the object must be storing not null. Otherwise, you get a null pointer exception, which I will show to you later in the tutorial. Okay, so we use a dot notation to retrieve any of its attributes. Let's see this. And what we spoke about in the English tutorial is it's like off or something that belonging to the objects, right? For example, nationality of the context objects over here. Okay, so Jim's nationality. And let's see the usage over here. So you can either say Jim dot attributes, or you might say Jim dot some Mutator method, or you might say Jim dot some accessor method. So these are the three usages. And as I show in the tutorial videos, whenever you say the context object dot, so what that means is you're going to look up the address that is stored in the context object. Go to the look up the address and go to the memory for the objects, and then apply whatever either the mutator method or the accessor method or the attribute you want to apply, for the context object, right? That's the simple usage for dot notation. We will see next week about how you can use multiple dot notation in the expression. That'll be something I will explain in detail next week. All right, and once we talk about dot notation for the simple usages, let's talk about the this keyword. Okay, the this keyword is really important, but let's now motivate why it would be useful. Okay, and let's say this. Let's say we got this point class over here, and then we got actually two attribute. We got x and we got y, and also we got some mutator method over here, right? And because the parameter over here does not clash with any of the attribute values, so we are okay. So we can simply say y. Unambiguously, y is simply means the y in the attribute over here. It cannot be. It cannot really mean any of the parameters, right? All right. So now, whenever we are calling a method, we must specify the targets, the call targets, or the context objects, right? So that's something you want to get used to. Whenever I talk about targets or context object, they're really interchangeable. All right, let's now take a look at this piece of code. We got P1 and P2 being created, and then we say P1 and P2 being the context object for the same method call, right? The two method calls of the same method. You can see we're calling move up, we're calling move up as well, right? So here is the question. Okay, let's see the question here. So first of all, P1 and P2, they are the call targets or context object. That they are different for sure. And then line number 3 and 4, we're simply applying the same method. We're calling the same method twice with a different context object. But now, how does Java distinguish the change to? So here you can see when we are executing this move up, we are calling this move up over here. And then we are now supposed to update y. But what y are we updating? Similarly, when we are calling this move up over here, we're calling this move up again. However, what y are we really changing, right? So now we want to know whether it's going to be p1.y or p2.y. That's something we want to see. So how do we know? How can Java compiler tell? Or how can Java runtime actually make sure the corresponding y value is going to be changed accordingly, either because of P1 here or P2 here, right? So that's why this keyword is actually present, or either explicitly or implicitly, to help you disambiguate. Let's see this. Okay, in the method definition, so here the method I'm talking about either constructor or accessor or mutator. Whenever you use the name, that's actually implicit. Use the name that's the same as an attribute, right? So each attribute has an implicit this, which refers to the context objects. So remember, in the definition, in the template, we use the keyword this. However, when we try to call the method, we're going to replace the this by the context objects, right? That's something I will try to review again, how to trace it at the end. Let's say here we got point, we got x and y, and here, let's say implicitly, even though the this dot and this dot, they are not necessary. However, you can still put it. They are not necessary because the new x is different from x, and also new y is different from y. So if I simply say x without this dot x, it's quite obvious x is simply just referring to this, right? But that's okay. But here, when I say this dot x and this dot y, so this over here is referring to whenever you're trying to use this particular constructor, there will be some context objects that's in question. In that case, you have to replace the this by that particular context object, which can be anything. Similarly, if you are using the defining the move up method over here, the this keyword over here will also be replaced by whatever context object that's going to call this method here, right? Let's see this. Let's see exactly how this will be in effects, right? So this one, I'm not really illustrating this because we have seen this already in the tutorial videos, but I'll put everything together in a final example later. All right, let's say this. Let's say we got P1 over here. And then when we say P1 move up 3.5, so that means when we execute the move up method over here, we're going to replace the this by P1. That's what we will do. You can see here. So now rather than this, it will be as if we put P1 over here, right? And then when we call move up, it will be as if we put P1 rather in place of this, right? So you can think about the highlight in yellow over here is about the effects when you make this particular method call. We simply replace every occurrence of this in the definition by P1. All right. Similarly, when you talk about P2, so now the context object is different. So that's why it would be replacing every occurrence of this by simply just P2. And this simply corresponds to how I illustrated in the tutorial videos for your week number 6. Okay, and let's see this. And yeah, exactly. So this one just to emphasize, even so that's why usually Java developer, they will prefer simply choose the same name as the attribute over here if you want to use a parameter to override it. In that case, you can simply this.x is simply referring to the x over here, and this.y is really referring to the y over here. On the other hand, without this over here, because you can see the x is clashing with x over here and y is clashing with y over here, there is a phenomenon called variable shadowing, which I defined in the later slides. Variable shadowing simply means under the scope of this particular method, if you simply say x, it will not really mean the x in the outer scope. It will only mean the x in the inner scope, which is x over here, right? And y is going to refer y over here is only going to refer to the y over here. All right, let's now see some common error. Okay, so let's say here you chose the name for the parameter name, which clashes with name, and also h also clashes with h attribute over here. But now you say name is assigned to name and h is assigned to h. So this will be a logical error because of variable shadowing, you can see the name over here is really referring to just the name over here, even though what we intend to do is to really refer name to be the name over here because of variable shadowing. Okay, so that's what you will see, variable shadowing over here. Okay, and the definition is, you can see that that's exactly what I just said, right? So now how can we resolve this? What will be the fix? The fix will be, we want to say the left hand side here, what we really meant to say is to go past the shadow. We want to go past the shadow and refer to this particular name. To do it, we got to say this dot, okay? Right, in that case, we're going to say this dot name over here, which will refer to the name. And the name over here, because of shadowing, is going to refer to the name over here. So now, this particular variable assignment will be exactly what we intended. All right. Okay, let's now talk quickly about mutator methods and also accessor method, and then we'll do some tracing quickly. Mutator method should only change the values of the attributes without returning anything. Okay, and then also with a void return type, right? You can see the most important thing is a void and without any return statement. You can see the example over here for both classes. And also for accessor method, you're gonna need to return something. And then the return type should be something other than void, right? It can be primitive type like a double, or it can be reference type like a string, and other classes as well. Okay, you can see I'm just using this over here. I would say what I would recommend is sometimes even though this keyword is implicit and may not be necessary, let's say there's simply no variable shadowing, in which case this will not be necessary. But I would suggest you still put it always there, just to say very explicitly that I'm really referring to the heights for the attributes. All right, for accessor, all you gotta remember is for the accessor number 1, it's going to return something that's not void. Number two, it is not supposed to modify the attribute value. It's only going to use the value for the attribute to do some computation, and then eventually going to have at least one return. I would say always have a single return for the method. It'll be easier to check the logic for your method. Okay, just a return over here. Right, everything has been also covered in the tutorial, so that's why I want to just touch upon the important points for you. All right, let's talk about method calls over here. So let me trace and visualize this particular example very quickly together with you, just to put everything together. Let me now switch to my iPad.